Okay, welcome to our session again. This is another second part of this video. Uh, Sadly, at the beginning, we have an assignment. You have to prepare this assignment. Like, first one is analog electronics overview, where you have to write something about resistor, inductor, capacitor, rectifier, transistor, etc. Different kind of transistors. So what I want from you is, number one, what are these? Number two, mention their working principle. That means where you can use it, how does it work. Then why those are important for development of digital system. Why this is so important in our digital system. So that things you have to cover, you have to understand, you have to mention. Okay. Second thing is about digital electronics overview, like as you learn in your DLD course. Okay, so logic gates, full adder, half adder, synchronous, asynchronous counter, multiplexer, demultiplexer, decoder, encoder, flip-flop, etc. Okay, the most important part is you have to think, you have to search, you have to say how these digital logic components are important for building a computer. Okay, the previous one was for digital system, but this one is for computer. Okay, so why these things integrated together and build a computer. So I will have another lecture on it, but I want you to prepare by yourself so that I can understand your level. Okay. And next is number system overview. Since this is important, like you shouldn't forget your name, you shouldn't forget your father's name, you shouldn't forget the number system. Okay, whenever I will say at least until 20, if I'll say any number, you should say the corresponding hexadecimal number very quickly or binary number very quickly. Okay, at least first 20 numbers. Okay, so that's why I just want you to review the number system, then the 2s complement for how just revision. Okay, so how subtraction can happen, and then shifting, left shift, right shift. You know, left shifting means division, left shifting means multiplication by 2, and right shifting means multiplication division by 2. And also for communication, this kind of shifting is very important. Okay, so I want you to review this thing and write this thing on a document as an assignment. And lastly, please, LSI, MSI, VLSI, all these are very important part of our life for our computer digital system. And also the new thing came is called nanotechnology. Okay, so you please take a look. Okay, I don't want any very big assignment, but nanotechnology, please write a bit elaborative study about nanotechnology. Okay, so this is the assignment for you. I will let you know your submission date. Okay, in the slide. Since I'm preparing in advance, I'll let you know the date. So this is the digital system architecture. Very important architecture. For information, it can come to your final exam. You can get this kind of question on your midterm. You can also have some question on it in your some class test or assignment. Okay, so this is very important figure. Okay, looks complicated but not really. Take a look. At the middle we have processor, high-end processor, low-end processor. On left we have input unit. Okay, the same like your computer, basic architecture of a computer. Input, processing, output. So we have input unit. Here we also have two kinds of input. One is I'm mentioning here high level input, which can be called as peripheral device, and then the low level sensor input. Okay, and on the right the same way, output peripheral device or low level output device like sound or display or monitor. Okay, or motor action. Okay, like this kind of things. So input, processing, output. Processing means I have divided in two ways. One is high-end processing, where processing is very important. The most important thing is processing. And the second is low-end processing. That means where control system is the most important part. We can call it microcontrollers based system or control system based system. Okay. And between input and processor, there is interfacing. You know, in interfacing course, you knew, like, for any kind of communication, two things, okay, we need an interfacing device. So for high-end device, we are calling it interfacing device, and for low-end device or low-end processing module, we are calling it as a calibration circuit. Okay, calibration can be hardware, can be software calibration. Okay, and on the right side, in the same way, for high level output device, we are calling it interfacing, and for low level, we are calling it controller circuit, okay, driver circuit. Okay, so we just divide two parts, and at the top we have communication module. You know, nowadays, as I told you, IoT, communication. Without having the communication, even if you forgot your cell phone in your home, if you don't have the communication medium in your pocket, you will feel like I have something I have lost, like my arm, like my leg, maybe something I have forgot in my home. Okay, even you can continue your life with the money bag, but you can't continue your day without a cell phone. Am I right? So that's why the communication is so important. So yes, for communication also should have the ability of interfacing with the input device or the processing device or the output device. Okay, communication is nothing but you will have RX and TX, transmission and receiving. Okay, for transmission, if it's wireless transmission, then you have to make a sine wave or some wave. Okay, if you make a wireless connection, then you should create some radio frequency. Okay, and also you have to have the antenna to catch that radio frequency. And to communicate with our computing element, you should have interfacing. Like, you got the signal, but how I am going to make it understandable to my processor? So that's why we need interfacing. That why interfacing is included with all the input or output or with the computer or the processor. Okay. For one thing is important. As I told you, IoT device, like, there will be some device that will just sense the environment and will send the data to our computer. So just one module can make by using input sensor, interfacing, and communication module. Okay. In the same way, for output also, like, I am controlling some light or fan. Okay, I don't need to have any high-end processing device. Just it will receive some information. It will, by using a driver or controller, okay, it will turn on the fan or turn on the light or turn off the light. Okay, so that's why different interfacing and different communication can happen. And at the bottom, I use the power. Okay, the power section is divided into some dotted lines. Okay, why? Because to make you understand that, yeah, some part might need different power supply, or any single power supply can power up all the resources or all the components of the computing system. Okay, like in our computing system or in our computer or in our mobile, everything is powered with the same battery or same 220-volt connection. But if you go for some other projects like Duguri, like Mongolturi project, or like Chandrabot projects, we use 3-4 types of power unit. Like, one power unit is only for wheel driving. Okay, one power unit is only for processing element or NUC PC or Beagle board. Okay, Jetson TK. Okay, we use Jetson TK for bracket Duguri. So, because when the motor start running, it installs huge current, and because of that voltage drop, and our computer can get restart. Okay, so to avoid this thing, we use different power supply for processor or for computing device, and different power supply for motor. Okay, in the same way, communication also the same thing. So that's why the power unit is can be same, one power unit for everything, or separate power unit for separate things. Okay, so that is the system architecture of a digital system. Okay, so keep in your mind, this is very important. Now the system overview, as I told you, in hardware, input, processing, output, you can see here, sensor overview and hardware calibration circuit will be discussed in this part. Okay, and then processing device, there are a number of types of processing elements around us. Okay, for computer, yes, this is a type of just a type of computer. Like, yes, you have there are Core i5, Core i7, but it's a different type of processor than our mobile processor. Okay, our mobile processor is different than the processor we are using in computer, and this is almost the same type of processor we are using in our Raspberry Pi. Okay, so we have different type of processor, like, and also for the Arduino, we are using totally different type of processing element. Okay, we are using microcontroller. We are not even saying this thing microprocessor, we are saying microcontroller. Okay, so different type of processing elements are there as a hardware. Okay, as a hardware, different type. As a software, also different type of things are available, because some systems can support Windows, some system can support Mac OS only. Okay, nowadays Mac PC also can support Windows, but before some days, different type of hardware was for operating system was for different type of hardware or computing system. Okay, and then output. If you say the output, then actuator or effector and their controller. We are going to discuss this thing in this section. Okay, so in hardware section, we are going to discuss this thing, and in software section, programming for interfacing and calibration. Okay, yes, so how to interface, how to calibrate, how to understand the environment. We are going to have the discussion of this kind of algorithm or this kind of programming, and then we are going to discuss about control programming. Control program is very simple. You know the if else, while do loop, case structure. So by using only this few structure and then some functions, you'll be able to make the control program. But for communication programming, you need to know the details of communication, like how to interface with one, how to maintain the protocol. Okay, like this protocol to that protocol. There are a number of types of communication protocol, like NFC, okay, RFID, this kind of different type of communication. So how to make communication with different type of communication module. So that is the part we are going to cover as in software part. Okay. Methodology. So system development methodology. So methodologies for digital system implementation. We are going to discuss how we can what kind of methodology you can use for digital system research and development. Okay, and then research scope on digital system, like as I told you, different type of scopes are coming. Like before some days back, I got a proposal to to advise them how can we make a digital system for protecting the elephant when, like as you know, one rail line is start making from Chittagong to Cox's Bazar. So and there are some places where elephants are coming and walking around. So to save elephant, they want to use some digital system. So you see, so here is also again there are some other way, like they're fenching, okay, around the line. Okay, so if you fench, that means the elephant cannot cross that road. Okay, it have to walk all the way, or maybe if some elephant become angry, it will break the fence. So that's why they want digital system to protect you. Okay, so it's everywhere. So what are the research scope of digital system development? Okay, and lastly, scope of publication of digital system. How can we publish? Okay, where we can publish? What are the scope of publication? Okay, these things we are going to cover in digital system design methodology.